How's it, great class? So I'm going to be continuing with exercise 9.3, and I'm going to be doing number 4. Okay, so let's just have a see what it says here. The graph of the function f of x is equal to ax cubed plus bx plus c has a turning point at minus 1, 0. So we have a turning point over here. And it cuts the y-axis at minus 2, which is over there. We need to show that a is 1, b is minus 3, and c is minus 2. Okay, so question A. They've given us f of x is equal to ax cubed plus bx plus c. All right, I'm just going to write down the information that they've given us here. They've told us that we have a turning point at minus 1 and 0. And then we have a y-intercept at 0, minus 2. Okay, so what I'm going to do first of all is I'm going to use this point over here because I know that f of 0 is equal to minus 2. Basically, our x is 0 and our y is going to be equal to minus 2 from here. So I'm just going to put 0 in here for my x's. So we get a times 0 cubed plus b times 0 plus c equals minus 2. Okay. Now, you guys are probably thinking, how do I know how to do that? I don't. Okay, I'm just using the point. That's all I'm doing. I would have done it for any other point. Just put it in here and then see what it gives me. Okay, so over here we get c is equal to minus 2. All right. So our function over here now becomes f of x is equal to ax cubed plus bx minus 2, because we know what c is. Okay. So now what I'm going to do is I'm going to use this turning point. Now I know that f dashed of minus 1 will be equal to 0. Now again, great tools, it's not this 0 that I'm talking about. I'm setting this equal to 0 because the gradient is 0. Why do I know that? Because it is a turning point. Okay, so what we're going to do is we're going to, first of all, we're going to find f dashed. So f dashed of x will be equal to 3ax squared plus b. Okay, put minus 1 into here and we get 3a minus 1 squared plus b equals to 0. So that's just going to give us 3a plus b equals to 0. Okay, I now need another equation because I've got two unknowns. I need two equations. And that's where this point comes into play now. Now I'm going to use it as a coordinate point. So now I know that f of minus 1 will be equal to 0. Now I am using that 0. So I'm saying when my x is 0, when my x is minus 1, my y is 0. And that's what that is saying. Okay, this is saying my derivative of minus 1 is 0 because y, it is a turning point. So over here, I'm just going to plug in minus 1 into the original equation here. So we get a minus 1 cubed plus b minus 1 minus 2 equals 0. That's going to give me minus a minus b minus 2 equals to 0. Over here, I'm going to solve for the b. So we get b is equal to minus 3a. You can call this equation 1. Call this one equation 2. So we're going to sub 1 into 2. Okay. Right, so in equation 2, wherever I see a b, I'm going to replace it with minus 3a. So we get minus a minus 3a minus 2 equals 0. So that's going to give us minus a plus 3a, which gives us 2a equals 2. Just taking that to that side. Divide by 2, so we get a is equal to 1. I'm now going to sub this into equation 1. So sub into 1, and we get that b is equal to minus 3 times 1. So b is equal to minus 3. All right, guys. So what I've got here is I've got my C value, I've got my A value, and I've got the B value. So let's just double check here. They said show that A is 1. So our A is 1. B is minus 3. B is minus 3. And then C is minus 2. C is minus 2. Okay. So question B. Question B, they're saying calculate the coordinates of the local minimum turning point A. This one over here. Okay. So now that we've calculated A, B, and C, I can put it into that general formula. So this is question B. So f of x was equal to ax cubed, and our a is 1, so that's just going to be x cubed. Bx, and our b is minus 3, so that's minus 3x, and our c is minus 2. So that's our function there. So in order to find this other turning point here, to find turning points, we need to take the derivative and set that equal to 0. Why? Because our gradients are 0 at the turning points. So f dash x equals to 0. In other words, our gradient equals 0. So let's differentiate this, and we get 3x squared minus 3 equals 0. Okay, I'm going to divide through by 3, and we get x squared minus 1 equals 0. I can factorize that, and we get x plus 1, x minus 1. So x is equal to minus 1, or x is equal to 1. Now, we are not interested in this one because that's already this turning point over here, minus 1. We're interested in this one, and our x value needs to be positive there. So this one over here is not applicable. Okay. Now, the question was to find the coordinates. So I need to take this, put it back into the original to find the y value. So f of 1 will be equal to 1 cubed minus 3 times 1 minus 2. So that gives us 1 minus 3 minus 2. It's minus 5. So that's minus 4. Therefore, A has the coordinates of 1 and minus 4. Okay. Right, question C. Calculate the x-intercept at B over there. All right. So question C. To find x-intercepts, we make this equal to 0. So f of x equals to 0. That means that we get x cubed minus 3x minus 2 equals to 0. Now, with this, grade 12s, yes, you can use your calculator, okay, to find the roots for this. But just be very careful, because you're not going to get the marks that you deserve. You must show how you factorized it, okay? So we can use the calculator, and I will show you how. You just press this mode button, and then we're going to press 5 for equation, and then number 4 because we're dealing with a cubic, okay? And all I do now is I put my A, my B, my C, and my D values in. So just remember that your general is y is equal to ax cubed plus bx squared plus cx plus d. So they're talking about this A, B, C, and D values. So our A value here is 1. Our b values with the squared, or the x squared, which is 0, because we don't have an x squared. Then our c is with the x, so it's over here, which is minus 3. And then our d is the constant, which is minus 2. Press equals again, and we are getting one of those roots over there. So x, and now just reverse it, grade 12, so that's going to become minus 2. Okay? And as you'll see, we'll get minus 1, and that just gives us those 2. Now, the reason why it's only giving us 2, because you remember at this point here, we've got equal roots. So in fact, we've got 2 of those things there. Okay? So I'm going to basically cheat, because I know that it's going to be x plus 1, x plus 1. All right? X plus 1, x plus 1. Why? Because I just reversed that root, which is minus 1, so it'll be plus 1. And why am I writing 2 of them? because we have equal roots. Okay, so here we're going to get x is equal to 2, or x is equal to minus 1, or x is equal to minus 1. Now obviously we're not interested in these two because we've already got that. We're interested in this b1. So therefore b is the coordinate to 0. All right. Right, let's have a look at question D. Question D says, determine the point of inflection. Okay, so to work out points of inflection, we have to find the second derivative, and we set that second derivative equal to 0. Okay, so I'm just going to rewrite what the original was. So we've got f of x is equal to x cubed minus 3x minus 2. Find the first derivative. So f of x, or f dash x, is equal to 3x squared minus 3. Find the second derivative, and we are going to set that second derivative equal to 0. That is how we find points of inflection. So f double dash of x equals to 0. Now that is going to find our point of inflection. Okay, so let's differentiate the first derivative, and we get 6x equals 0. So that means that x is equal to 0. What I need to do now, that's my x value for my point of inflection. I need to take that, put it back into the original to find the y value. So f of 0 equals 0 cubed minus 3 times 0 minus 2. So f of 0 is equal to minus 2. Therefore, the point of inflection has a coordinate of 0 minus 2. All right, question E. Here. For which values of x will f double dash x be greater than 0? Okay, so all I have to do for a question like this is I know what my second derivative is. Okay, it's the 6x. And they're asking for which values of x will f double dash x be greater than 0. So just take your second derivative, 6x, and set it greater than 0. And then you can solve. So if I divide by 6, I get x is greater than 0. Okay, as easy as that, guys. Then, question F. Question F is asking, write down the values of x for which f dashed x is greater than 0. Okay, now there's two ways we can do this. We can either look at the graph, or we can actually solve it algebraically. Now, just remember what this is saying. It's saying f dashed is basically your gradient. So it's asking, where is our gradient positive? So a positive gradient is going in that direction. So you can see that your graph is positive over here. Okay, so all of this is a positive gradient. At that point, it's a 0 gradient. Then in that direction, it's a negative gradient. At this point, 0 gradient, and then back to positive. Okay, now we've worked out what coordinate A is. We did it in question B, which is over here. So we know that this x value over here is 1. Okay, so what I'm going to do is I'm just going to read it straight off the graph. And it's asking for where is the gradient positive. So it's positive all the way here, and this is going towards minus infinity. And it's positive all the way to where x is minus 1. Then from minus 1 to 1, it is negative. Then after 1, it is positive again. So we're going from 1 to infinity. Okay, so infinity always gets a round bracket. This minus 1 is a turning point, so it is a gradient of 0. But this is asking strictly greater than 0. So we cannot include that one. And likewise, we can't include that one because the gradient there is 0. We've got two solutions, so I need to put a union there. And x is an element of those numbers. Okay. If we look at question G, write down the values of x for which f of x is equal to k has only one root. So with this type of one, what I'm going to do is, if I put it like this, f of x equals k. all right? Now we know what our f of x is. It's this thing over here. So x cubed minus 3x minus 2 equals k, basically. So if we take that k to the other side, it becomes a minus. So we get x cubed minus 3x minus 2 minus k equals 0. Now just remember what k is. It is a constant. It is just a number, okay? So we've got a case here when k is positive. So if k is positive over here and I take it to the other side, it's going to be a negative number. Now what would that do to our graph? Subtracting a number. It would shift our graph down, okay? So it's going to take this entire cubic and move it down by k units. So for example, if this was 3, I take it to the other side, it becomes minus 3. So that means I'm shifting the graph down by 3 units. So if k is positive, that means we're moving the graph down. If k is negative, in other words, a negative number, so let's just say minus 3, for example. If I take minus 3 to the other side, it becomes plus 3. So that means we're moving the graph up by 3 units. Okay, so that is a shift up. So what we're interested in here is we are interested in how many units must we move this thing up or move it down so that it has only one root. What does that mean to us? That means that it only cuts the x-axis once, okay? So over here, I can see that it's cutting the x-axis there, but over here, it's cutting it twice. Just remember, we have equal roots here. So if I shift it down by just a point of a number, my graph is going to come down like this, up like that, and you can see now it's only going to be cutting once because I've moved it down and that turning point is no longer there. So all I have to do is just move it down by anything that is greater than 0. Okay, so just remember that a positive thing is moving it down. So my one thing is k must be greater than 0. Okay, for example, if it's 1, take it to the other side, becomes minus 1, shifts it down. But we can also make it 0.1 or 0.00001. And you see we're moving it down a little bit, but it'll still cut the axis once. Okay. On the other hand, we can move it up. And we need to move it up to such a point that this turning point will now be over there. Okay. And the graph will go up like that. And obviously that will come up and like that. And that is the one now that we're interested in there. We want to shift it up enough such that that turning point there doesn't touch the x-axis anymore. Okay. Now we know what the coordinates of A is. Coordinates of A is 1 minus 4. We worked that out in B. So we know that this here is minus 4, or the y value. Okay, so that means that that is 4 units long. So if we look for where it's negative, it must be this one. So k must now be less than minus 4. Okay, when it is 4, let's just make k 4, minus 4. Take minus 4 to the other side and it becomes a plus. So that means we've moved this thing up 4 units and now it's turning on the axes. We don't want that because that is still an x-intercept. So anything just less than minus 4 or greater will move it up such that this does not turn on the axes anymore. So that is your solution over there. You get the 2, x greater than 0, x less than minus 4. All right, thanks grade 12. I'll make another video now.